Hello everyone. So, in chapter Adsorption and Colloids, today I am going to talk about properties of colloidal dispersion. Let's start. Properties of colloidal dispersion. The general properties are: colloidal system is heterogeneous. It is consisting of two phases, dispersed phase and dispersion medium. The dispersed phase particles pass slowly through parchment paper or any membrane, but readily pass through ordinary filter paper. The particles usually are not detected by powerful microscope. Optical activity. Optical activity, we are going to talk about the Tyndall effect. Tyndall observed that when a light passes through the true solution, the path of light through it cannot be detected. However, if the light passes through a colloidal dispersion, the particles scatter some light in all the directions, and the path of light through colloidal dispersion becomes visible to the observer standing at the right angle to its path. So I can say that the phenomena of scattering of light by colloidal particles and making the path of light visible through the dispersion is referred as Tyndall effect. The bright cone of light is called Tyndall cone, as you are seeing in the diagram. Tyndall effect is observed only when the following condition is satisfied. Number one condition is the diameter of dispersed particle is not much smaller than the wavelength of the light used, and the refractive indices of dispersed phase and dispersion medium differ largely. Importance of Tyndall effect. It is useful in determining the number of particles in colloidal system and the size of the particle. It is used to distinguish between colloidal dispersion and true solution. Another property of colloid is color. Color of colloidal solution depends to the wavelength of light scattered by dispersed particle. For example, mixture of few drops of milk and large amount of water appears blue when viewed by scattered light and red when viewed by transmitted light. It also depends on the size of colloidal particle. For example, finest gold sol is red in color, whereas with increase in size it turns up into purple. Now, the kinetic property. The colloidal particles undergo ceaseless random zigzag motion in all the direction in the fluid. This motion of dispersed phase particles is called Brownian motion. British botanist Robert Brown observed such motions of pollen grain under microscope. The random motion was explained by Albert Einstein. The reason of Brownian motion is the constant collision of particles of dispersed phase with the fast moving molecules of dispersion medium. Due to this, the dispersed phase particle acquire kinetic energy from the molecules of dispersion medium, and this kinetic energy brings forth Brownian motion. Electrical property. The movement of colloidal particle under an applied electrical potential is called electrophoresis. Positively charged particles move towards the cathode and negatively charged particles migrate towards the anode and get deposited on the respective electrode. What is the application of electrophoresis? On the basis of direction of the movement of the colloidal particle under the influence of electric field, it is possible to know the sign of charge on the particles. Another application is it is also used to measure the rate of migration of soil particle. Third application would be mixture of colloidal particle can be separated by electrophoresis, since different colloidal particle in a mixture migrate with different rates because of their size, obviously. Now emulsion. Emulsion is one kind of colloid. A colloidal system in which one liquid is dispersed in another immiscible liquid is called emulsion. There are liquid-liquid colloidal system in which both liquids are completely or partial immiscible. Types of emulsion are, there are two types. Number one, emulsion of oil in water, or O by W type. An emulsion in which dispersed phase is oil and dispersion medium is water is called emulsion of oil in water. For example, milk, vanishing cream, paint. Emulsion of water in oil. The emulsion in which dispersed phase is water and the dispersion medium is oil. It is called emulsion of water in oil. For example, cod liver oil consists of particles of water dispersed in oil. Now, properties of emulsion. Emulsion can be diluted with any amount of dispersion medium. On the other hand, the dispersed liquid, when mixed, form a separate layer. The droplets of emulsion are often negatively charged and can be precipitated by electrolyte. Emulsion shows Brownian movement. It used to show tender liquid, and the two liquids of emulsion can be separated by heating, freezing, or centrifuging also. Now, application of colloids. Application of colloid. Number one, application in electrical precipitation of smoke. Smoke is a colloidal solution of solid particles of carbon or arsenic or dust in air. When smoke is allowed to pass through a chamber containing plates having charged smoke particles, they lose their charge and get precipitated. The particles settle down on the floor of the chamber, and the precipitator is called quaternary precipitator. Second application is in purification of drinking water. Water obtained from natural sources containing colloidal impurities, and by adding alum we used to remove colloidal impurities by getting them precipitated or coagulated. In medicines, colloidal nature used to be used. Colloidal medicines are more effectively in to large surface area to volume ratio of colloidal particles and easily assimilation happen with this colloidal medicine. Argyrol is a silver salt used as an eye lotion. Milk of magnesia is also an emulsion which is used as an antacid. In rubber industry, rubber is obtained by the coagulation of latex. Cleansing action of soap and detergent is based on this colloidal solution. And in photographic plates, films, and industrial products like paints, in synthetic plastics, rubber, graphite, lubricants, cement are colloids.